Okay, so this is what we have done. What we have done is we have completely seen how we will write program as a in pen and paper. Okay, we have completely debug each and every passes. Okay, to get a clear-cut understanding. Fine, we have completely seen time and space complexity. We have completely seen uh, how to find out the maximum element. Okay, and the theory part. Hey everyone, so in the last video we have already seen bubble sort. Okay, we have seen that how to sort array or list using bubble sort algorithm. Okay, we have seen time and space complexity and we have also coded the example. In this video we are going to see the selection sort. Selection sort is another technique to sort array elements. Okay, so let's see the selection sort. Okay, selection sort algorithm. Okay, so now what is selection sort algorithm is? Suppose an array is given to us, that is 3, 1, 5, 4 and 2. Okay, this is the array given to us. Now you will be asking like, okay, what is a selection sort? Now the answer is selection sort means we need to select an element and place it in a correct position. Okay, we need to select an element and place it in a correct position. Okay, suppose we have selected the element 5. Okay, we have selected the element 5. So what is the correct position of 5? The last, because 5 is the among 5 is largest element. Okay, and we need to sort. That means our target will be our target will be after sorting. The array should look like 1, 2, 3, 4 and 5. Okay, this is only the sorted form of this array. So we need to select the element 5 and place it at last position. Then we need to select another 4 and place it at second last position. And then we need to select 3 and place it at third last. And then we need to select 2 and place it at second last. And then 1 and place it at the final fourth last. So here we will got our sorted array. Using this principle only we will do selection sort, and using this principle the selection sort based on the algorithm based on, as per the name suggests, that selection means we need to select an element and then place it at its correct position. Okay, now what I have done is, see, what I have done is I have taken the largest element and placing at its correct position. You can also do with the smallest element. Just take the one smallest element and then place it at its correct position. And then take 2 and place it at its correct position. Then 3, then 4, and then 5. Okay. So in any way you can do it, but I'll go for the largest one. Okay. So let's see how we will proceed it. And let's first write the steps. So what are the steps to achieve it? Okay. So steps. Step 1 is you need to find out the largest index. Okay, the largest index. And the step 2. So what is the largest index is? Largest element index is only the largest index. What is the largest element here? 5. And what is the index? 0, 1, 2, 3, 4. So 2 is the largest index. Okay, so first you need to find out that largest index, and then uh, you need to swap it with n minus I minus 1 largest element or last element. Okay, what we have done here, so let me write again because it is somewhat messy. Fine, so our array is 3, 1, 5, 4 and 2. Okay, and this will be a target array. Okay, we want to sort, so it becomes this array. Now we have selected this element and then place it at last position. Okay, last position. Now we have selected that element and place it at second last, and then third last, and then fourth last, and then fifth last. Okay, so now what we are doing it, first we are calculating the largest index. Okay, and then we are swapping this largest index element with the last. Then we are again calculating the largest second largest index. that is this. Okay, and then we are swapping it with that second largest, second last element. Okay, largest with first last, then second largest with second last. Similarly, we will do till we got this array. Okay, so now how we will do it? How we will do it? Okay, because there is one error. So what is the error is? There is one problem. So what is the problem is, if the array is 3, 1, 5, 4, and 2. Okay, so initially we have selected 5 and place it here. Okay, so our array will become 3, 1, 2, 4, 5. Okay, we have selected largest index and then we have swapped it with the last element. So our array become this. Okay, after swap. Now again, if we calculate the largest element, okay, so again largest is this. Now again we are swapping it with the last element. Okay, see here. Initially we have done this. Okay, this is the first step. We have taken the largest element and then swap it with the last element. Okay, again we have taken the largest element and swap it with the second last. So in this way all the element will become 5, 5, 5, 5, 5. But we don't want it. Okay, we want that we need to now check in this array. Okay, first we have checked in the whole array. In the whole array largest element is 5. Okay, so we have swapped that 5 with the last element. Now 5 is already at its correct position. So now we need to check in this array. Okay, after we need to check in this array. After we need to check in this array and after this array. And that is why repeating these steps we got this 1, 2, 3, 4, 5. Getting? That is why I have placed the condition here as n minus I minus 1. Okay, as I is increasing, we are just decreasing our iterations and iterations. Okay, and iterations. Fine. So I hope you get clear. Now we will see how we will implement this in a programming. Okay, and try to implement it. Okay, so our array is 3, 1, 5, 4, and 2. Okay, fine. So what we need to do is, first we need to initiate a for loop. I less than arr.length. Okay, and I plus plus. Fine. Now we need to calculate first the last index. What is the last index is 0, 1, 2, 3, 4. Okay, so last index is n minus I minus 1. Okay, here n equal to arr dot length. Okay, length of array. Now why I have taken 1, I have already explained that. See, initially in the first case last index is this, then the last index would be this, because after the first round, after the first pass, 5 got here, 5 came here, so we need not to check in this. Okay, we will see, we will debug it. Okay, and then we will see. Fine. Just now for consider, last index will be n minus I minus 1 and n is arr dot length. Okay. Then what we need to do is the largest index. Okay. So int maximum index. So we will create a method, another method, that get me maximum index. Okay. And we will pass array. We will pass 0 as our start index and we will pass last index. Okay, this is the last index. We'll pass here. Okay. So get me maximum index. Okay, we will create another method here itself. Okay, we will create this method here. Get me maximum. 1 second. Space problem. Okay, so I'll create this method here itself. Get me maximum index. Okay, and int arr, okay, int start and int end. Okay, fine. Now we need to calculate the maximum index. If you don't know how to calculate the maximum element or maximum index, then I'll tell you how to calculate is I'll tell you how to calculate. See here, in a very short way. Suppose you are given the same array. Okay, you are given an array is 3, 1, 5, 4, and 2. Okay, this is the same array you are given. First, initialize a variable max, which is equal 0. We are just considering that, okay, 0 element is the maximum element. 0, 1, 2, 3, 4. We are just considering that our 0th element, the element present at 0th index, is the maximum element. Okay, with this consideration, we are just checking. We will check each and every element that any element will greater than it or not. If it is greater, then we are assigning that index to this. So to check each and every element, we will initialize a for loop I less than arr dot length and I plus plus. Okay, fine. Now we will check if arr of I is greater than arr of max, then max equals I. Okay, so this is the program. Now suppose this is initially we have our max index is 0. Okay, we have assumed that our 0th element is the maximum element. Loop started. Now it is checking each and every element that arr of I, initially I is 0. Okay, so arr of I, that is 3, is greater than arr of max is also 0. So 3 is greater than the 3, condition false. Again I plus plus, now I becomes, initially I is 0, I plus plus I become 1. So ARR of 1, what is ARR of 1 is 1. 1 is greater than ARR of 0, that is 3. No. I become 2. ARR of 2, which is 5, is greater than ARR of max is 0, that is 3. So 5 is greater than 3, yes, condition true. So max initially was 0. Now max changed from 0 to I. What is I here? 2. Then again I equals 3. So what is 0, 1, 2, 3? ARR of 3, that is 4. 4 is greater than ARR of max. Now max is 2. Okay, that means 5. So 4 is not greater than 5. Similarly 2. So that's why we return max. Okay, that means max is 2. So the element present in second index is the maximum element, and which is the correct answer. Okay, so don't worry, we will see using debugging also. Fine. Using debugging, you'll get a clear-cut understanding. Okay. If you're not able to explain that, okay, I don't know like what is happening, don't worry. Watch complete video and till end. If you don't get, then you'll ask in comment. Okay, because after debugging, there is zero possibility that okay you'll fail to understand. Fine. Okay. So this is where we will find the maximum element or maximum index. Okay. So in this way only we will find here. Okay. So int max equals this as, which is a start. Okay. Same way we'll initialize the for loop int I equals 0, I less than arr dot length, not arr dot length, I less than last index. Okay, and I plus plus. Why last index? I'll explain. Okay. This is the end index. Okay. We have taken E. We have taken E. So okay, so I less than E and I plus plus. Okay. See here, we are passing start index as 0 and last index as what we are calculating from here. So start at 0 and E. Okay. Now we are just checking if ARR of I is greater than ARR of max, then max equals I and we are return max. Okay, the same way we have done here, same way. Okay, fine. Just the end condition got changed. Now here end condition is the last index. Okay, so from here we are getting the maximum index. Fine. The next step is swap it with the last element, or n minus I minus 1, which is the last index only. Okay, so swap it with the last element. Fine. Or it is better to say like swap it with the n minus I minus 1 largest element. So what is n minus I minus 1? The last index only. Okay, so swap it this maximum with this. So the next is swap uh, last index with maximum index. Okay, so let's create another function. Swap here. We are passing array. We are passing index 1 and index 2. Okay, so if you don't know, then if you don't know what is swap, then you can see bubble sort. In that I have in detail explained like how to swap the two elements. Okay, and we've also done the program for that. So just please watch bubble sort video. Okay, so how to swap it? We'll initialize a variable temp. Okay, and store index 1 value in that. Then arr of arr of index 1, arr of index 2. We are storing index 2 value in index 1, and then index 2 as temp. Okay, so in this way we got swapped these two element, the element present at last index and maximum index. Okay, now let's debug it. Okay, without debugging you will not get a clear cut understanding. So let's debug it. Fine. So what is our array is? Our array is 3 1 5 4 2. Okay, so let's yeah, so now let's see the using debugging. Okay, so the first thing we initialize the for loop. Okay, last index is n minus I minus 1. What is n is 1 2 3 4 5. Okay, length 5 minus I is initially 0. Okay, I initially is 0, or we will write here itself, right? We will write here itself for loop for int I is 0, I less than n 1 I plus plus. Okay, now last index is 5 minus 0 minus 1, which is 4. Okay, n minus I minus 1. Okay, then maximum index is, we will pass arr 0 and last index. What is the last index? Last index we got as 4 and start index as 0. Okay, so from here we will calculate our array is 3 1 5 4 2. So last index is 4, that means 0 1 2 3 4. Okay, so till 4 we need to find the maximum element. Okay, because last index is this. Okay, so for loop runs from start 0 to 4. So 0 to 4 maximum element is maximum index, which is 2. Okay, because this is only the maximum element, so maximum index is 2. So we got here 2. Next thing is swap. Okay, so swap 4 and 2. Swap 0 1 2 3 4, 4 and 2. So our new array will be 3 1 2 4 and 5. Okay, this is the pass one. This is pass 1. Okay, now pass 2. How to start pass 2? See, we are doing this operation in for loop. Initially I equal to 1. Again control come here, and I got incremented. Okay, now I equals 2. Initially I is 0. Now I equals 1. Okay, I equals 1. Fine. Again calculate for pass 2. Again calculate last index. Now I is 1 and 1. Okay, so 5 minus I minus 1, that is 5 minus 2. So last index is 3. Okay, maximum index. We need to pass ARR 0 and the last index, that is 3. So now in this case, if our array is now the updated array is 3, 1, 2, 4, 5. Okay. So start index is 0 and end index is 3. 0, 1, 2, 3, 4. See, this is where I have written here n minus I minus 1. Why? Because in the second pass, the 5 is already at its correct position. So why there is a need to check in that? We don't need to check. So only we need to check in till the third index. That is why I am writing here n minus I minus 1 as my last index. Okay, so I need to check in this array. What is my last index? My last is this. My last element is 4. So last index is 3. So I am getting my maximum index, that is 3. Okay, my maximum element is 4. So my maximum index is 3 only. Okay, so 3. Now the next thing is swap. Swap 3, which is last, and maximum 3. So the same element. So the array will got as 3, 1, 2, 4, 5. Okay, now these two elements got sorted. This is what pass 2. Again, I got incremented from 1 to 2. Okay, so pass 3. Pass 3. Again, I got 1 to I equal to. Last index is 5 minus I, which is 2 minus 1. So 5 minus 3 is 2. Okay, maximum index array start is 0 and last index is 2. Okay, last index is 2. That means if our array is now 3, 1, 2, 4, 5. Okay, so last index is 2 means 0, 1, 2. So now we need to check till here only. What is our maximum element? Maximum element is this. That means maximum index is this. So it is getting 0. That means maximum index is 0. Next thing is swap. We need to swap last and maximum. What is last? 2. And what is maximum? 0. Okay. So now we need to swap 2 and 0. 2 and 0. So our 2, 1, 3, 4 and 5. Last 3 got sorted. This is pass 2. Pass 3. Okay. Again pass 4. Pass 4. When I equals, initially I is 2. Here I is 3. Again calculate last index. 5, which is n minus I is 3 minus 1. 5 minus 4, which is 1. Maximum index. We are passing array start at 0 and last index 1. Okay. Now it will check if my updated array is 2, 1, 3, 4, 5. Okay. So I need to check the maximum index in range 0 and 1. What is the maximum range? What is the maximum index? Maximum element is 2. So maximum element is 0. It will get 0 here. Okay. So my maximum index is 0. Last thing is swap last and mi means maximum index. That 1 means or 0. So after swapping 1, 2, 3, 4, 5, and which is our answer. Okay, so this is what we got the answer. Fine. I hope you got clear cut understanding. Okay, I've completely explained using step-by-step procedure. I've also completely explained using how we will write the code in our IDE. Okay, I'll explain that how to calculate the maximum element. I've explained the theory part. Okay, the only thing remaining is time and space complexity, stability, and then code the example. So let's see time and space complexity. Okay, what will be the time and space complexity? So space complexity is O of 1. It is a constant space complexity. Why? Because we are not taking any extra auxiliary space. Not taking any extra auxiliary space. Okay. Why? What is auxiliary space? See, we are not initializing any extra array. Okay. And we are not storing any element into that array. Okay. That extra space means we are not taking any extra variable or any extra array or any extra data structures. Okay. And not using throughout the program. Fine. That's why it is a constant. Time complexity is O of n square. Why O of n square? You can see with the program. First, we are getting the maximum index. Okay, while getting the maximum index, we are traversing through complete array. Okay, see here. Now you will be asking, no, we are not traversing through complete array. Initially, we have checked complete array. Okay, in the second pass, we have checked the first four element. Okay, in the third pass, we have only checked this. In the fourth pass, this two. Okay, fine. I agree with you. So what is your statement is in the first pass you have checked n minus 1 array. N minus 1 iterations have done. Okay. See 0, 1, 2, 3, 4. What is the last index? 4. Okay. So till 4 you have checked like what is my maximum index. You need to calculate the maximum index, right? And the start and end index is 0 and last index. So first the last index is 4. That means 0 till 4 you have checked. Okay. And 4 is what? N minus 1. So initially you have checked n minus 1 iterations. Okay, you have done. Then n minus 2. Then n minus 3. And then n minus 4. Okay. See first 4 iterations and then 3. So what is 4? N minus 1. N minus 2. N minus 3. N minus 4. That is 1. So total iterations are n minus 1 plus n minus 2 plus n minus 3 plus n minus 4. Okay. So this is the total iterations. Fine. Now let's calculate how much iterations. Okay. Because what is the time complexity? How my time grows as my input grows. Okay. How much iterations my program is taking. That much amount of time my program will take. So n plus n plus n plus n. 4n. Minus will take common. 1 plus 2 plus 3 plus 4. 4n. And what is the progression value of this? N into n plus 1 upon 2. So n into n plus 1 upon 2, if we solve it, then 8n minus n square minus n upon 2. Okay, so 8n upon 2 minus n square upon 2 minus n upon 2. These two are less dominating term. Why? Because if the n is 100, if n is 100, okay, so it is increasing square times and they are increasing linear time. Okay, so in front of n square, these two are less dominating, and in time complexity, we will eliminate less dominating terms. That is why the overall time complexity is O of n square. It is in the worst case. Okay, and in the best case also, it is O of n square only. Why? Because you can see in bubble sort, we initially get to know that yeah, it is a sorted array. What is the best case? Best case means if the array is given to you is sorted only. That is the best case. Okay, so if the array is given to you is sorted, so initially how you get to know yeah that it is sorted. Okay, in bubble sort how we are doing it, we are using two pointer method. Okay, we already checked that okay if j pointer is not get swapped once, then the array is sorted and we've stopped the iteration. That's why the in best case in bubble sort the time complexity is O of n. Okay, but in this case it should not O of n, it is O of n square, because definitely we'll not get to know that, okay, before completing the program we'll not get to know that it is sorted or it is not sorted. If it is the array sorted only, then also we need to follow this procedure to find out the to get the element or to get the array sorted. Okay, maximum index and swapping. In swapping there is nothing like, okay, we'll get to know prior. Getting my point? So that's why in best case and the worst case, in both case, time complexity is O of n square. Okay, so this is what time complexity. The next thing is stability. Stability of selection sort algorithm. So selection sort algorithm is not stable. It is not stable. Okay, what is the stability? If you don't know, then you haven't watched my bubble sort video, because in that video I've already explained in the complete detailed way what is stability and how to check that it is stable or not. Okay, so first watch the bubble sort video. So selection sort is not stable. Okay, now just remaining is coding part. Code the selection sort algorithm. Okay, so now let's open our IDE. Okay, so here our Eclipse. Now we have already created one project. Okay, we have done bubble sorting. Now the second type of sorting, that is selection sort. We'll create a class. Write the name selection sort. Okay, so here the class is created. So first we will write the main method. Okay, in that we will first initialize our array. What is the array is 3, 3 comma 1 comma 5, 2 and 2 and 4. Okay, and then we are just calling get me sorted array. Okay, we are passing the array and we are printing it in our console. Okay, how we will print the complete array? I've already shown in the first linear search video that we need to use toString method to print the complete array, as it will print the hash code value. How to read hash code of 1D 2D array I've already shown you. That is also done. Okay, now let's create this method static. What we are returning? We are returning the sorted array. That is why the return type is array, and the method name is get me sorted array. Okay, what we are getting it? Int arr. Okay, fine. Now what the very first thing we have done? The very first thing we have done is very first thing we have done is we have initializing a for loop. Okay, the same thing we are going to implement there. Nothing change, and that is why this is the best DSA course ever. Okay, so let's initialize the for loop. Int I is 0, I less than 0 to from 0 to arr.length. See, we've already studied in a pen and paper. This is just a formality. I plus plus. Okay, then we are just calculating mid last index, which is n minus what is n? Arr dot minus I minus 1. Okay, see here, n minus I minus 1. What is n? Arr dot length. Okay, arr dot minus I minus 1. Then maximum index is will again uh, declare a method get me maximum index. Okay, and we are passing it, what we are passing, array and 0. and last index. Okay, see the same thing. 0, last index and array, and we are creating the get max index method initially, that externally. Okay, so let's create that method. Static int, and what we are getting, int arr, int start, int end. Okay, and then we are calculating maximum. Initially we have initialized that the max is 0. We are assuming that okay, 0th is our maximum element index. Then from int I equals start to I less than, and I less than equals and I plus plus. Okay, then we are checking one by one element that if arr of I is greater than arr of max. If yes, then max equals I and return max. Okay, fine. Here we are getting the maximum index. Now the final thing is swap last index and maximum index. Okay, now let's create the swapping method. Static void swap. We are getting int index 1, int index 2. Okay, so the last step is swap. In the swap we are getting array index 1, index 2. Okay, so array. Okay, now how to swap? For int I 0, I less than arr dot length, and I plus plus. Okay, int temp equals arr of index 1, arr of index 1 equals arr of index 2, and arr of index 2 equals temp. Okay, and here it got swapped. Fine, and finally we are returning arr. Now let's print, let's run it. Java application. So it's running. Yeah, 1 2 3 4 5. Let's add one more element, 8 0. Again run it. 0 1 2 3 4 5 8. Okay, the array is got sorted. Now let's debug it. Final thing is let's debug it. Okay, so debug means executing the program line by line. Okay, control stops here because we have already added debug point here. Control stop here. The array is passed as 315248 initially. Okay, next the last index is 6 because n minus ar dot length. What is ar dot length? 1 2 3 4 5 6 7. 7 minus I is initially a 0 minus 1, that is, so 7 minus 1 is 6. Okay, maximum index. What is the maximum index? We got 5. 0 1 2 3 4 5. This is the maximum element, so maximum index. We'll add debug point here also. Okay, and here also because it is directly jumping it. So now unit 2 last index is 6 and maximum index is 5. Okay, and array is this, so we need to swap it. Okay, so it's a swapping process going on. Don't worry, I have already explained in the linear search. You can just go there. I'm not gonna explain again and again. Okay, so array got swapped. If I hover an array, you can see 8 come at its correct position. Fine, 8 come at correct position. Now we need to check the maximum index in this, not in this. That is why now I got 1. So my last index is 5. Okay, my last index is 5. That means while calculating the maximum index, okay, I'm passing a maximum index and maximum index is my end index. So I'm just taking from start, that is 0 to end. What is my end? End is my maximum index. What is the maximum index? This is the last. No, here. Okay. So end is this last index. Okay. And what is my last? 5. That means 0, 1, 2, 3, 4, 5. Okay. And now updated array is this. So I just need to check in this part of array. I leave it. That's why I put here ar.length minus I minus 1. Okay. After, see here, when I just, it came here. Okay. And the maximum element, it will calculate the maximum element. Okay, you just check. So what is the maximum index you got is 2. Okay, array is 0, 1, 2. See here. Among this array, the maximum is this. That is why, if suppose I'll take again complete array, then again maximum will be 8. So it will swap again 8 and 8 and 8 and 8. So it makes complete array 8. That is why I have taken this array. Okay, after swapping, 1 second. See, the array will be now you can see 5 and 8 at its correct position. Similarly, you can just go on and on and on and on, and then finally the I increase. Okay, then get maximum swap. I increase, get maximum swap. I increase, and finally you get the final sorted array. Okay, so this is what the selection sort is. I hope you get the clear cut understanding. Fine. If you like the video, then please comment down. Okay. And the next video, we are going to discuss insertion sort. Okay. So this is what we have done. What we have done is we have completely seen how we will write program as a in pen and paper. Okay. We have completely debug each and every passes. Okay. To get a clear cut understanding. Fine. We have completely seen time and space complexity. We have completely seen uh, how to find out the maximum element, okay, and the theory part. I hope you get a clear cut understanding, and then we will see the next sort in the next video. I hope you get the great understanding, and if you like, then please subscribe, comment down, and subscribe. Okay.